Good afternoon, everybody. My name is Dennis Hirsch, and I'm a professor of law at the Moritz College of Law, and importantly for this event, faculty director of the program on data and governance, which is a program both of the Moritz College of Law and of the Translational Data Analytics Institute, or TDAI, at The Ohio State University. And it's my pleasure to welcome you today to our second Data Points event of this year. The Program on Data and Governance, or PDG, as we usually call it, has a two-part mission. First, we conduct research on how to maximize the benefits and minimize the harms from advanced analytics and AI. Secondly, PDG engages the community, both at the university and outside of our university, in a conversation about how we as a society can best govern advanced information technologies so that they vindicate rather than undermine our values. And we try to engage in this conversation and facilitate and convene this conversation in a number of ways, including through our Data Points lecture series in which you are participating today. Now, most of the programs that we have and most of the speakers that we host on Data Points and our other venues focus on the threats that advanced analytics and AI pose and how to address and reduce those threats. And that's really also the tenor of the social conversation today, particularly with respect to the negative impacts that these advanced data technologies can have on social justice and equality. That comes up a lot today when people in the media and elsewhere in academia are talking about advanced analytics and AI. And these concerns are well-founded, and it's critical that we as a society and we as academics address them. But by focusing so hard on these concerns about the negative impacts, we sometimes forget to ask whether advanced data technologies also have the potential to advance social justice and equality, and if so, how they might do so. And this too is an important area for imagination and creativity. Few have applied their imaginations and their efforts to these questions more than our speaker today, Rediet Abebe. Dr. Abebe is a junior fellow at the Harvard Society of Fellows and is an incoming assistant professor of computer science at the University of California, Berkeley. Her research focuses on artificial intelligence and algorithms with a focus on equity and justice concerns. One of the special things about her is that she does not limit herself to her cutting-edge research. She also takes action. Rediet is co-founder and co-organizer of Mechanism Design for Social Good, an interdisciplinary research initiative that uses techniques from algorithms, optimization, and mechanism design to improve access to opportunity for historically underserved and disadvantaged communities. She also co-founded Black in AI, a nonprofit organization tackling representation and equity issues in AI. In her bio, Dr. Abebe writes that her research is influenced by her upbringing in her hometown of Addis Ababa, Ethiopia. It gives me great pleasure to introduce you to Rediet Abebe today. Before I do so, I also need to let you know that we would not be able to put on these events, including our Data Points events, without our partners. And in particular, we could not offer the Data Points lecture series without the support of our series sponsor, the law firm of Porter, Wright, Morris, and Arthur. And we thank Porter, Wright for its vision in understanding the importance of these data governance issues and for supporting this lecture series to enhance all of our understanding of these issues. And now it is my great pleasure to introduce you to Rediet Abebe and to invite her to share her ideas with you.
Thank you so much, Dennis. I really appreciate that incredibly kind introduction. I'm just going to first do screen sharing, make sure that things are working, and then we can get started. So just to confirm, you can now see my slides? I'm going to assume yes, but if that's not the case, let me know, and then we can change that. Very good. Okay, so it's such a pleasure for me to be here. This was an event that was long planned, and it got shifted with everything going on. And I'm really glad that we were able to find a time to give me this opportunity to share my work with you all, and for me to get a chance to interact with you. And I hope this will be the first of many conversations that we'll have. So really want to just say a huge thank you to the organizers. This has been much harder to plan than other events may have been because of this shift. So today I'm going to share with you. It's a paper that I wrote with my colleagues at Cornell. So this was a paper where we wanted to provide a framework that made sense to us of how would we use computing for supporting social justice and broader societal changes that are so desperately needed right now. But using that as a framework, I'll also share with you some of the other projects that I've worked on with other colleagues and also other people's projects that I think are really important in this space. So we'll be able to cover quite a bit of ground with this. But we'll first start by just recognizing everything that's going on, right? So the world is going through a really, really hard time. For instance, here in the US, we know that violence against marginalized communities, including Black and African American communities and immigrants, has really reached a breaking point in 2020, although this is a longstanding issue. We're in the middle of a global pandemic, which is still pretty unbelievable, and millions have been infected and died because of this pandemic that is still spreading in a pretty uncontrollable way in many parts of the world, including here in the US. And the screenshot I have is from a few weeks ago. And so, these numbers are probably like wildly outdated, right? Because this is a serious issue we're grappling with as we speak. And the other issue is that these challenges that I mentioned to you are sort of intersecting with one another and feeding one another in these incredibly unsustainable and crushing ways. So if we take the pandemic, for instance, we know that it disproportionately impacts Black and African American individuals, American Indian individuals. We know that it impacts lower income families and other marginalized groups, right? And so these groups are significantly more likely to be infected, to be hospitalized, and to die because of this virus. And likewise, we know that in the US, immigrants who constitute a significant portion of our essential workforce are effectively shut out of a lot of the assistance that they desperately need and that the government is able to provide, right? So a lot of families who have not been able to receive the first stimulus, a lot of families that are immigrants or have an immigrant within the family have not been able to receive the first stimulus. And really, this sort of much needed economic relief is not really being provided for many families anyway, right? So we're really in a situation where people who are marginalized and doubly and triply marginalized and so on are really under a sort of crushing amount of disadvantage that will be very difficult to work through. And so, you will ask, what are we going to do, right? And in particular, in my case, because of my training in algorithms and computational techniques, my knee-jerk reaction in these situations is I have this set of skills, and I would like to help. These problems are serious and affecting people as we speak, and we would really like to it's an all hands on deck situation. Really like to do what we can to move the needle on these things. And it's not really just during this urgent moment. We know that these problems that I mentioned and the many others that I did not mention are long-standing problems. They've been around for a very long time. The need has always been there. The need to provide relief for families has always been there. What's changing now is that it's kind of becoming very difficult to ignore them because the pandemic has sort of brought a lot of things to the surface in a way that they hadn't in the recent past. Right. So we ask ourselves, there's a lot of change that's needed, that's long overdue. what can we do? And in particular, do computational techniques have anything to offer here? And in asking that, it's important to just look at what we've done so far, right? It's not very difficult to see that there's been situations in the past, even few years, in the past, less than 5 years, where algorithms that are designed, even with vulnerable communities in mind, have actually created or perpetuated or exacerbated inequality. Right. So, for instance, there's a recent study that shows that a lot of healthcare algorithms have very deep anti-Black racial bias. There's work by Virginia Eubanks that shows that even algorithms that are designed to alleviate poverty have actually created unfortunate circumstances whereby it was penalizing individuals living in poverty and shutting them out of assistance, right? And so these are three that come to mind immediately, but we know of many, many instances where algorithms that are designed, including those designed with vulnerable communities in mind, have actually done the opposite, have had the opposite effect of what we would like for them to have. And more generally, critical scholars, there's way too many of them to list here, so I'll just kind of synthesize the points here, but critical scholars have pointed out that there's common pitfalls for using computing for social good. And a sort of a high level summary of some of the main criticisms is solutionism, which says that there's potentially a tendency to assume that computational techniques on their own are going to solve social problems. So this kind of mindset that maybe we can center algorithms, we can center computational techniques, and that will provide the solutions that we need. There's a sort of tinkering that happens also, whereby we take problematic aspects of our society, the status quo as given, and we sort of try to optimize around it. And so that kind of detracts attention away from the root of these problems, the root of these injustices, and instead says that we can just shuffle money around in this way, make it a little bit more efficient, and maybe that's going to provide a solution. And then the last very important critique to keep in mind is a diversion, which is that a lot of times once you say algorithm, then all the attention or AI, once you want to say AI or algorithms, all the attention kind of gets concentrated around that. And it can detract away from other forms of addressing these societal problems, and it can detract away from the problems themselves, right? So it can kind of suck the energy out of the room in a way that we don't necessarily want. And so that's a lot of, really challenging news. And in particular, if you're someone like myself, you might ask, okay, well, here's a set of techniques that I like and I'm able to contribute to, and here's a set of societal problems that are pressing and we want to do something about them immediately. And is there a way for me to bridge these two things? Do computational techniques have any role to play, or is it better for me to just abandon that side of things and retrain in some other field that may be more useful in this setting? So this is a genuine question that it wasn't even a research project when we started this. This was a genuine question that me and my colleagues were asking ourselves, and we had many years of conversations around these challenges that we see in using computational techniques and the very pressing societal problems that we all deeply cared about. And so in doing that, we came to a set of a framework that I'll mention to you, sort of partially mention to you, although I direct you to the paper if you're interested in seeing the details of it. But we came to this realization that social change is the work of many hands, and certainly computational techniques can be part of the solution, but we have to think very critically about what roles computational techniques are well equipped to play, and how that might fit with other roles that other disciplines or other domain experts might be playing in this space, right? And so we thought carefully about how computational techniques can support other routes to broader social change that we definitely need in this space. And so there's 4 roles that we identified. I'm not going to mention all of them here in the interest of time, but I do want to kind of dig into 2 of them, and especially the first one I want to discuss in a little bit more detail, just to give you a sense of what we were thinking about, and also, because I think this is one framework that's really helpful, or has been helpful for me. So the first role we identified for computing is the role of computing as a diagnostic. This is one that you might think of almost immediately, right? It's something that comes very naturally to us, which is that if you're using computing, and here by computing I mean techniques and algorithms, optimization, sort of data science, machine learning, right? And so if you're using these set of techniques, you are able to measure a lot of things, right? You can pick whatever it is that you want to measure, get data around it, and try to get a sense of how you would measure the extent of that thing. And so that thing can be a social problem that we're interested in. And so if you're interested in, let's say, poverty measurement is a challenging issue. And so you can use a set of techniques that we have here to try to get a better understanding of the extent and the depth of poverty. And this is especially easy for us to do in situations, it's especially important for us to do, and I shouldn't say easy, this is hard, but important for us to do when these sort of social problems are manifesting themselves in technical systems. As an example, you can think back to the work of Latonya Sweeney. Latonya Sweeney is a professor at Harvard University, and her 2013 paper on racial bias in ad delivery is one of the first cited papers in this area of algorithmic fairness. And in this work, what Professor Sweeney shows is she shows that if you, at the time, if you were searching for names that for names that are associated with African American individuals, including, for instance, Latonya Sweeney, you are more likely to get these these ads on the side that are related to either being arrested, defaulting, right? Things like sort of negative, things that have negative social and economic connotations associated with them, and not just connotations, but also experiences associated with them, right? And so she was showing this, and this was sort of, to our knowledge, one of the first papers that tries to do this sort of diagnostic, right? It says you have a bunch of names, you can search for these names, you get different experiences based off of that. Do we see discrimination here, and in particular here by racial discrimination against African American individuals or individuals with African American names? So this is sort of one of the first works that you see. But again, it can, you can more immediately see here that like this was a project, a research finding that was sort of diagnostic. But really, a lot of the other examples that you might think of in this space are also have this diagnostic nature to them. So work by Joy Bulamwini and Timnit Gebru on facial analysis and discrimination by gender and skin tone is one. All the other ones that you might think of, right? Bias in word embedding, the healthcare algorithms ones that I mentioned to you earlier, bias in speech recognition, so on, right? A lot of these are really focused on measuring the extent of a discrimination on something, right? And oftentimes this is a technical system. They're measuring discrimination within a technical system. And to just dig deeper a little bit into how one might be able to do this, I want to share with you all work that I did with some colleagues at Microsoft Research and Stony Brook University on using search data to understand people's health information needs. And so this is an example of a diagnostic project where we were really interested in data inequalities, meaning that we recognize that, for instance, in health, which is what we focused on, we know that a lot of communities of individuals from marginalized communities are underrepresented data sets. And so we don't know enough about them, and therefore acting on interventions here can be much harder. And so we focused on HIV and AIDS in Africa, and we wanted to focus specifically on people's health information needs. And the idea here is that we know information is really key to combating many diseases, including and especially HIV and AIDS. We know that what information people have about when to get tested, about how the disease is transmitted, how to care for yourself if diagnosed with HIV, how to kind of get the help and support that different families and caregivers might need. All of this information is really, really key to managing the spread and the impact and the burden of the disease. And yet we're in a setting in a lot of African nations where even basic information is hard to come by. So here you can see a screenshot of a death certificate that shows a pretty serious error where it's not actually possible to tell what this person died of, right? So even basic information around what did people die of is really, really difficult to come by. So for instance, in South Africa, it's known that something like about half of the death certificates contain a very serious error. And so if you're in a setting where you don't even know let's say how many people died of AIDS, which is the setting that we're in, then you're certainly not going to be able to have a lot of detailed information about people's health information needs, what knowledge they have, and what misinformation might be spreading. And so what we did in this project was to use search data to measure these unmet and understudied and underexplored health information needs of individuals. And we used a set of sort of topic modeling, a set of techniques from natural language processing to synthesize these information needs that individuals have. So we found that there's a lot of things that you'd expect around symptoms and antiretroviral drugs and breastfeeding and pregnancy with HIV, but then also things that we know are very difficult to talk about, like stigma and discrimination in HIV, natural cures and remedies for HIV, healthy lifestyles, things like that. And so we were able to use this data set that was already there to examine what information people were seeking related to this condition across the continent. And you can really dig deep into this and really try to measure the different types of topics that people are looking at. So if you look at the natural cures and remedies topic here, so here you have like the cluster of words that kind of represent the topic, but you can actually dig deeper and see what types of queries are associated with that topic. So here you see that people are asking questions around different prophets healing AIDS or HIV and prayers around it, but also questions around black seed oil, olive leaf cures HIV, and like different herbs and other edible things curing HIV, but also some things that are, that are hopefully not, being eaten, like things like, baking soda or chlorine dioxide, right? So really, there's a lot of different types of effectively misinformation around what cures HIV and what cures about treatment and management of HIV and AIDS, right? And so this was, in some ways, it was once we had the data, once we had analyzed the data, it was kind of easy for us to kind of try to pull a lot of these insights, but it ended up being incredibly valuable in this space because if you're in a setting where you don't know what people know, what they don't know, what misinformation might be out there, it's really, you have this like cold start problem, right? If you're surveying people, going around asking people questions, and you said, hey, what natural cures and remedies exist for HIV, that already, that might already flag people as being like a, something that maybe they don't necessarily want to talk about with a stranger, right? It's really hard. And if you don't know that there's people out there who believe that chlorine dioxide cures HIV, you wouldn't know to ask that. Right? This is a very difficult thing to guess. And so in a sense, you can think of the analysis that we did as a sort of providing a sort of cheat sheet for health organizations for just knowing what baseline information is out there. And so we've been able to share this, and this has been able to support some survey design for these health organizations. But what we're really interested in, again, is this diagnostic flavor of computing, right? And so what we wanted to do was we thought, okay, people show up and they ask whatever question they have, like, does garlic cure HIV? Very common search query that we saw. What information are they getting? Well, here we find that if you use this as an example, the top query that was highlighted is a website called miracleofgarlic.com. And not only was it the top webpage that was shown, it was actually highlighted as like an answer, right? So a lot of people were clicking on it, and it had information that I, even as someone who has no formal training in health or medicine, could immediately see had a lot of issues of accuracy and issues of accuracy and objectivity. But in comparison, if you instead ask for antiretroviral therapy HIV, right? So one of them is about natural cures and remedies, and the second one is about scientific drugs and remedies, then the web page looks very different. So not only do you have the top website being something that was rated quite highly by our research assistants who have formal training with graduate level training in health and medicine. So they rated this website highly, but actually the whole webpage looks very different, right? If you look at the right-hand side, it has a Wikipedia page highlighted on managing HIV and AIDS. It also has It also has suggested queries around, table of FDA-approved antiretrovirals and drug interactions and things like that, right? So these two pages look really, really different, right? What you're seeing here, where you have a very low quality web page highlighted versus this other thing that you see where the web page that was highlighted or the first web page that you see is high quality, but also actually the whole page looks very different, right? And so what we were able to do in this work was we quantified using, working in collaboration with health experts, we were able to quantify the quality of content that people are getting depending on the topic with which their search queries are associated. So we found that in our data set, a lot of queries associated to stigma and breastfeeding and drugs got a rating of 4 or above out of 5 on average. So these are web pages that were rated to be high in relevance and accuracy and in objectivity by health experts. But search queries related to natural cures and remedies rated at about 1.5 out of 5, meaning that there were serious issues in relevance and accuracy and objectivity. So a lot of times these were blogs and Yahoo Answers and other low quality web pages. And potentially equally concerning is that also symptoms, questions related to symptoms and symptoms of HIV were also rating at about 2.7 out of 5. So it's a very popular topic related to HIV and AIDS. A lot of people ask about symptoms of HIV and it's not always that they're getting high quality information, as I mentioned. So this was helpful for us to see. And there's a lot of reasons why this might be happening. So the first thing is that people are searching for specific types of things. We don't necessarily have control over that. And so, but we just recognize it as a potential source of disparity. But there's other things that we found. So we were able to see that web pages do a sort of back end processing when you type a query. So for instance, if you type something and there's a typo, then it might automatically correct that typo before mapping your search query with a set of web pages, right? So this kind of back end processing that it was doing that significantly less for searches associated with natural cures and remedies. You can see that that's one of the lowest, whereas questions around drugs and stigma were rated quite high, right? So this was one important finding. And the second one, which to me was quite shocking, to be honest, is the availability of web pages from high authority websites. So if you were searching for, does garlic cure HIV, but you only wanted to see web pages from the CDC, the UNH, NIH, WHO, then I would be able to show you potentially 0 web pages. Maybe there's actually no web pages that I can show you, but oftentimes I would have maybe 1/5 the number of web pages that I would have had if you were asking for questions related to drugs, related to HIV, right? So in some cases, if you were asking for something, there might be literally no web pages I can show you from a high authority website. And so regardless of what the search engine might be doing, any sort of issues of bias there, it could still be the case that there's just not enough content from high authority websites. And so we were able to sort of not just measure people's health information needs, but also look at this full ecosystem, identify different sources of bias, and try to get a sense of how we can measure potential sources of disparities and discrepancies that would eventually feed into what content people are walking away with. And so we've been able to work on different aspects of health and diagnostic issues with health, including through a working group that I was a part of at the NIH, where we worked on a set of recommendations and a report for the general director and his advisory committee. And we were able to share this, and the report can be found on my website. But we've been really able to see through these types of studies, our own study, but also other people's studies, and try to ensure that it's impacting policy and practice as well. And so this is sort of like one example, the example that I really wanted to go into detail about the role of computing as a diagnostic. But one thing that's incredibly important to keep in mind in this space is that it's very tempting to assume that if you just know the extent of a problem, if you can just measure it, then you now have the solution. But we know that this is not the case. So there's a quote by Ruha Benjamin, a professor at Princeton University, which says, "Data in short do not speak for themselves and don't always change hearts and minds or policy," right? And the idea here is that we know that there are social problems like mass incarceration or sort of chronic homelessness, chronic and very prevalent homelessness in U.S. cities, that there's very deep awareness of the extent of the problem and that it's a huge issue that we should be addressing, and yet we haven't really done anything about it, right? And so it's very important to keep in mind that just because we've diagnosed a problem, it doesn't mean that we're now going to solve the problem, that there's political will to solve the problem, that we even know how to solve the problem if we did, right? And I'm not saying this as like a technical computer science problem, but just like as a societal problem overall. And so it's very important to keep that in mind. But we also know that computational techniques have been used as a treatment, right? Here we're saying that diagnosis is not a treatment, but they have also been used as a treatment. So in my corner of computer science and mechanism design and algorithm design, there's many examples around allocation of kidneys and seats in public schools and low-income housing resources and many other things, right? So the first of these two examples are things that have happened for so long. There's, Professor R. Roth won a Nobel Prize in part for his work in informing allocation of seats in public schools and allocation of kidneys, right? So we know that there is a space where algorithmic techniques especially have been used to inform these types of solutions. And so here, this compels us to think about the role of computing as a formalizer, right? We mentioned allocation of kidneys or seats in public schools. That's a social problem that you have to formulate as a sort of optimization problem to kind of come up with the solutions that I mentioned in the previous slide. And so what that says is that a lot of times in using these types of computational techniques, you're forced to be very explicit about what the input into your algorithm is, what the algorithm even is, what are your objectives, what are your constraints, and sort of how you're going to use or what format the output would look like. And so in a sense, what happens here is that this forces you to be concrete about things, and that can shape how these social problems are understood. So what do I mean by that? Well, if you're talking about things like, let's say if you say something like a social worker must act in the best interest of a child, right? This is something that many people would agree with, right? And it's very easy to agree to this statement. It feels very, good. Like, why would you not agree with this? But the issue here is not the statement, but rather what do we actually mean by each of these things? For instance, if I say the best interest of the child, what does best interest mean? If I say housing assistance programs aim to help the most number of people, what do we mean by help and what do we mean by most number of people, right? Actually, we have to be very concrete about this if we wanted to write this down as a sort of computational problem. And so that we found can actually create a place, something that we can grab onto to have deeper conversations around these sort of social issues that we would like to help address. And so just to give you a very quick example here, something that we've worked on that I'm very excited about was inspired by issues around eviction. And so here we know that there's massive eviction in the US. It's always been the case. And now with the pandemic, this has gotten even worse. And we know that one of the driving things behind eviction is these unexpected shocks that people might experience, right? Like maybe you have medical expense or maybe even a parking ticket or something happens. You lose your job briefly, maybe your check is delayed. So we know that these sort of unexpected expenses or interruptions to people's income flow could trigger a cycle of poverty that leads to eviction, poor health, job loss, all these things that are very painful for families to go through and very undesirable, right? And so we know that. And so what we were able to do in our project that I'm only mentioning in passing here, we were able to kind of come up with a very stylized model of economic welfare that incorporates not just people's income and wealth, but also different shocks they might be experiencing, right? So here you're seeing, a family's income, their reserve is going up over time as time goes on because of their income adding to it, but then they experience some shock, it drops, right? And so you can sort of track people's welfare in this way using the model that we provided. And then using that, we asked a bunch of different types of optimization questions around allocating income subsidies. And I'm not going to get into the details of it, although I encourage you to look at the paper if you're interested. But what we were able to show through formalizing this problem in this optimization framework and asking questions around how you would allocate different types of income subsidies what we learned was that we found that even in the stylized setting, information really matters. So if you're taking people's information about people's income versus information about their income, but also their shocks, you could actually be doing much, much, much better in the second instance than the first instance. We also found, really surprisingly to me, we learned that these objective functions that you're setting, right? In optimization problems, you have to say what your target is. So these objective functions that we're setting, sort of differences between them that look minimal, that look not that different, could actually be very consequential. So to give you one example, in this problem, we had a min sum objective, which said, I want to minimize the expected number of people that experience eviction, right? So this is a probabilistic model. So I'm like, I don't know, I'm not going to have concrete, like sort of definitive answers, but there's an expected number of people that might experience eviction in this particular allocation. So I want to minimize that. Or you can have a min max style objective, which says, I want to look at the person who has the highest probability of being evicted, and I want to make that as small as possible. So the first one, in a sense, is like trying to like kind of rescue the most number of people in expectation, and the second one is trying to lift the floor, right? So trying to make the most vulnerable person as less vulnerable as you can possibly make them, right? And so these objective functions look, they both look sensible, but we found that in our problem they can actually be giving you exactly opposite answers. So in one setting, it could say you should help these set of people, and the other one it might say actually you should be helping this other entirely disjoint set of people, right? And so we had these kind of insights. And what's kind of remarkable about this is that this was a very stylized model. The optimization questions that we asked looked like pretty kind of bare bones, like only the main ingredients of the problem. And already we were pulling out all these insights around how consequential this decision of objective function setting is, and how consequential what information we're taking about families or the type of intervention could be. And so what we were able to do with that was focus away from just this sort of inefficiency argument, right? Because we said, look, here we can optimally solve these things, and you still end up having these like drastically different solutions. And so maybe the issue is not optimally solving this thing. It could actually be that we just don't have enough budget set aside for assisting families. In the US, we know that like 3/4 of people who are low income and in need of housing assistance just don't receive any sort of housing assistance. And these numbers are worse in some parts of the country than others. And so if you're in a setting where you don't have enough budget to assist people, and actually that budget is going down over time, then the focus on efficiency detracts away from what's happening with the fact that we just haven't set aside enough resources for families. And so in a sense, what we were able to do using this optimization problem was to just show, look, this is not about optimally solving this problem, because even in this very stylized setting, I can show you all these inconsistencies that are completely undesirable in our systems. So that's sort of one more example that I wanted to share. I'll mention that there's two more roles for computing that I didn't mention in this talk, but if you look at the paper, they are you can find them there, and I'm happy to chat about it if you're interested in any one of these other roles. But I do want to take some time to go from, a lot of the examples that I showed you were about writing these papers, and it's, we got to start somewhere, so that's a good place to be starting. But actually seeing it through and impacting practice or impacting policy is a very crucial element. And a lot of things kind of fall through the cracks. And so what happens, right? One thing that happens is that I think there's a sort of hesitation to take full responsibility for how our research is understood and used. A lot of times you might hear people saying things like, well, we don't really consider that subpopulation, right? And this is like when something is really underperforming around that population, you say, oh yeah, I guess we didn't really consider, this particular subgroup, or I'm just the engineer, or I'm just the researcher, right? So this is an implementation problem. It's kind of out of my purview. I shouldn't have to worry about it. Or, oh, that's not really my job. That's a policymaker's job. Or, yes, there's this discrimination that you see here, but that's like really an implementation issue. If you look at the core algorithm, it shouldn't really be doing that, and things like that. And so there's a lot of different ways whereby we sort of normalized punting responsibility to others. And we've seen the consequences of that. And so it's really important for us to come back, right, and really take full responsibility and even proactively try to shape how our research is being understood and being used, and being very open to feedback and criticism from other domain experts that we might be working with. And the second point that I'll end on is to say that it's really, I think now we know that a lot of computer science that's happened in isolation has had unintended consequences that have been really bad, or intended consequences that have been bad, but that's a different can of worms. And so it's really important that we build partnerships with domain experts and affected communities. I actually think of affected communities as being also domain experts, but I just really want to highlight this, so I mention it separately. And we want to do that in a way that is based on mutual trust and respect. So in a way that's not extractive, in a way that's not a sort of passing collaboration, right? But a genuine partnership here that whereby everyone feels equally valued and heard and able to shape how we're able to move forward. And so I want to mention that. And one model for this that we're quite proud of, it's a work in progress, but we're still proud of it, is our Mechanism Design for Social Good Research Initiative, which is an initiative focused on the style of questions around using algorithmic and computational mechanism design techniques to improve access to opportunity for marginalized communities. So this is an initiative that I run with my colleagues that you see here, and we have various things. We have a community of individuals from over 100 institutions in 30 different countries. I'm sure this is actually an undercount. I haven't updated it, so it might be much, much higher. We have an online colloquium series. We have domain-specific working groups that are each meeting in parallel, focused on a particular space and really working in collaboration with a lot of different experts, different types of experts who are interested in that space. And all of this happens online. MD4SG has been going on for 4 years now. Almost everything we've done has been online, and now it's online out of necessity. But even once we're back to having more physical events, MD4SG thinks will still be online. And so I highly encourage you to join us. We have these domain-specific working groups. We have an online colloquium series where we've been able to highlight different experts, including Al Roth, whose work I mentioned earlier, Dr. Rabase, who's a leading expert in ICTD research, right? So we have these monthly colloquium series where we highlight these incredibly accomplished and successful researchers and practitioners in this space to learn from both their work and also just sort of their expertise about how to do research in this highly interdisciplinary area. And we also had a technical workshop series that has really grown into a much broader workshop series where we have different types of presentations, and it's now matured into a conference. So we now have it's going to happen in fall 2021, dates to be determined soon. It's likely going to happen virtually, but if physical events are magically possible, it might be happening at Columbia. And this is really, in a sense, a kind of a byproduct of this community that we've been able to together build and foster and really invest towards. And this is one of the products of that. And so we're very proud of this new stage that the community is entering. And with that, I'll stop. I'll highly encourage you to follow me or MD4SG on Twitter, ask me questions over email, or ask all the organizers questions over email, share your ideas. Anything that you'd like to share would be wonderful. We'd love to hear from you. And with that, I'll stop. Thank you very much.
Well, thank you, Rediet. That was really, really interesting. And it gives us all a lot to think about. Along those lines, I would invite the audience members to submit questions through the Q&A function. And I will then be able to see those and pass them on, and we can have Rediet address them. So I'll just start with a first question. It seems like one of the themes that you're talking about is having computer scientists and data scientists be more involved in kind of the social aspect of their work, right? As a formalizer, kind of helping to define what they're optimizing for, engaging with those social questions and value questions, taking responsibility for how their research is used, in policy and social science, et cetera. And so I guess the question I have is, speaking as someone coming from a social science field, law, are computer scientists well trained well suited to think about these kind of social science and policy questions? And if so, what do they bring to that conversation?
Right.
And kind of a parallel question, are there aspects of computer science or data science education that would make such people, such professionals, even better suited for this? And if so, what should we add to the curriculum?
Yeah, such a great question. I love that your second question was going to be my answer to the first question.
Yeah.
But I'll repeat it anyway. It's good. It's bears repeating. So so this is a dynamic problem, right? So there was 5 years ago, you could have polled the whole world and said, do you self-identify as a computer scientist, right? And you'd have a set of people who say yes. And then you can do that now. And I promise you that community looks very different. Even in the past 5 years, we've seen a huge difference. And I'm sure if I had been, around in this community for longer, I would have seen an even more drastic change, right? And so it's important to notice first that what we think of immediately as a computer scientist is something that is changing over time, and I think changing for the better. And so this is really important that we continue to update what we think of this community. And so I would say that, as a computer scientist, we're trained in a set of techniques. And I think these are techniques that could be really powerful in conjunction with other techniques as well. And so I guess part of my pitch is to say, yes, some computational techniques have been used to harm people, either actively designed to harm people or not necessarily considering everything into account and thereby still harming people, right? And so yes, that is true, but also some techniques, these same set of techniques can also be used to help people, right? And so I would say let's not throw them out. These are helpful techniques. In terms of computer science education, different universities have had different success, but on average, it is the case that we don't get sufficient training beyond the sort of technical things that we need, right? Obviously, I think there's exceptions here. So one obvious exception would be researchers in human-computer interaction or researchers in ICTD, I think, tend to have a more expansive training in terms of different fields that they are exposed to. And therefore, I find that oftentimes the way people look at problems is just different if you're an HCI person versus let's say a mechanism design person, which is the space that I'm in, right? And so I do want to acknowledge that difference. It is changing over time. A lot of universities are thinking critically about how to embed ethical training in computer science education, especially at the undergraduate level, right? Because we graduate a lot more undergraduates than graduate students. And so if you really can get to that community, you can do it well. I do think there's also structural problems here. So to give you an example, in the conferences that I would typically attend, right, not MD4SG, but everything else that I would attend, the papers that you see presented there are here's a problem, here's a solution, right? That's it. And that kind of skips a very important step, which is, well, how did you even define the problem? And have you convinced yourself this is an important problem to solve? Because some of the papers that we write are not useful to anyone, if we're just being honest, right? And so that step is skipped. And the reason why it's skipped is because I've submitted papers that were just here's a problem. It's an important problem. And, it's one that people have really tackled. I don't have a solution, but I'm going to convince you this is an important problem. So I've submitted those types of papers and they're not looked favorably by the community. It's not seen as a contribution, right? And so we're in this setting where this very important step is not incentivized and people therefore just don't do it because people have to publish some number of papers to graduate or whatever. And so in MD4SG, what we've done is we have a particular track for problem pitches. So we're you don't have to have any solution, just tell us about this domain, tell us about the concrete problem, tell us what people have tried, what are some hopeful directions that you see, right? And that itself would count as a contribution in the same way that any other paper submitted to the conference would as well. And so I think there's sort of structural issues, but I think that, there's nothing inherent to being a computer scientist. I think anyone who's interested in this field could be a computer scientist, and therefore I think any computer scientist, if they're willing, is able to work with with domain experts from other disciplines as well and make meaningful contributions.
That's great. Thank you. That's really helpful, really interesting. And I think we're trying to think about some of those issues at Ohio State. So it's really interesting to get your perspective on that. Rediet, 3 of our questions talk about the role that ML might play with respect to systemic bias. So let me just see if I can kind of combine them.
Sure.
One is, given that racism is structural in our society, how do we develop accurate measures of systemic bias? And another question is, if ML algorithms stumble upon systemic biases, should we remove them from the model to promote equality, or should we use those biases to steer the model towards promoting social justice? So those are 2 key ones. I
So
don't want to
the interaction,
give
the interaction, So good. So I appreciate that you're asking about systemic discrimination and bias, right? Because a lot of times when we think about social good, right, we often are focused on a symptom of a problem, and then we try to fix the symptom, but the underlying issue is still there. And so these systemic discrimination and bias issues that uphold our societal structure as is continue to just go on unaddressed. And so I really appreciate this question of just like, how do we even measure systemic bias, right? Because we know that there's sort of social scientific theories around, how discrimination or bias might be playing out. And we don't know the extent to which they're necessarily sort of out there, right? And so I do think that's like one frontier for contributions from machine learning and algorithms, to just say, okay, let's think about, let's say, intersectionality, right? Intersectionality we know is incredibly important, but a lot of times when we talk about discrimination, we just do one category, right? We just say male or female or, race, and that's it, right? And we just try to measure whatever it is that you're trying to measure. But we know that intersectionality is something that really matters. But this is something that gets challenging, right? Because you're looking at many different groups, like you have race, you have gender, you have class, you have immigration status, all these different things. And it becomes like a very, you have like this sort of exponential blow up in the number of different combinations that you could be looking at. And so it can make it harder to measure the extent of discrimination using, let's say, survey data or something, right? Because a lot of times survey data sets are small. And so if you're like breaking things up into small subgroups, you will have like not enough people to be measuring things. And so I do think this is a space where like we can use different types of data sets, and we can use insights from the social sciences and try to kind of really try to get at these types of things that would be difficult to measure using more traditional techniques. So I do think this is a space where we can contribute something. And then to the question around, you have an ML algorithm, it stumbles on systemic bias, what do you do about it? Probably that happens every single time. If you're using any data set that has people in it, it's probably has some sort of systemic discrimination or bias that's reflected in the data set. And there's many points at which that can enter, right? And so you might not even necessarily know where it's entering. And so you can't throw it out, because then you're just saying we should just not do machine learning and let's just move on. I don't think that's a good stance. And so I think just being aware of it, I also think just like humility could go a really long way here to say, look, we make these assumptions, we account for these things, we know these things are a problem in this space, this is how we've accounted for them, but there's also all these different caveats, and I'm going to be very honest and open about that, right? I think that could go a really long way. People do this in different ways, like so Timney Gabru, a colleague and friend of mine whose work is really impactful in this space, has papers around creating data sheets for data sets, right? Just saying, what was the data collected for, who collected the data, what issues are known, things like that. And so we can really think about that, right? Just, you don't have to throw things out, you should just be more mindful about it and also be very open and communicate clearly what's going on.
Thanks, Rediet. Here's another question from our audience. If you had a wish that would be granted, what would you change in the AI ML community?
Oh gosh.
Give you the magic wand.
But I can only change one thing. That's a hard one. Yeah, I think I know in some ways this is really a symptom of a problem, but I also think it itself creates a lot of problems. I think this divide between technical versus not technical is really weaponized in incredibly unhelpful ways. Um, I also think it's like not even, I think it's like a disingenuous distinction that we make, is maybe what I'll say, because I've seen problems where, someone goes through the following exercise where they engage with a domain, they identify a mathematical question, they answer that mathematical question. If that domain is, let's say, ad auctions, then our community is like, awesome paper, this is awesome technical contribution. But if that problem is poverty, then people are like, isn't that a social science problem though? Aren't you doing something that's like not technical, right? It could be the exact same process that you went through, exact same sort of like exercise that you went through. And so I really see it being weaponized in these incredibly unhelpful ways. I also think like we've absorbed it to an extent that we don't necessarily acknowledge. So maybe it's that, right? Just let's just abandon this distinction between technical and not technical, and just like think about like good work versus not good work. There's good work that's technical and good work that's not technical.
So we only have a few more minutes just for one last question. But there's a question about, the importance of democratizing data literacy.
Mm-hmm.
And that some regions of the planet, especially the questioner talks about Africa,
Yeah.
are falling behind. How do you think the international community or other actors, should address that issue and try and address this dangerous gap?
Yeah. So that's an excellent question. Maybe we're not going to do this question justice. So what I'll say is my colleague Abeba Brahane and I, along with several other of our colleagues, have a paper actually on precisely this, understanding data practices in Africa. And I'm Ethiopian, and I learned a lot through this process. A lot of my colleagues that we were working on this project were African, and we learned a lot about just how a lot of things we assume are just not true in the continent. A lot of things that we think people don't know, people actually do know and have creative solutions. A lot of issues that we don't recognize are actually caused by, you know, sort of the usual suspects, I should say, right? So just understanding this ecosystem of data practices and training in the continent is a wide open research area where I think significant contributions can be made. So I'm going to chat you all my colleagues' name, and maybe I would yeah. So Ababa or George, who I'm going to chat, I think would be wonderful people to invite at some point if you're interested in hearing the details of this project. So maybe I'll just chat them here. So here is Abeba.
Terrific.
Yeah, yeah. Because this is just really, really interesting
Great.
question,
Yep.
wide open.
Great. Well, and thank you to our audience for asking all these good questions. We're gonna end. We need to end now, but thanks to our audience for participating, and especially thanks to you, Rediet, for sharing your thoughts, your research with us. It's actually kind of been inspiring, so we appreciate that.
Awesome, excellent.
Okay.
Thank you so much for inviting me. I
Sure.
appreciate it. Thank you.
Okay.
Thank you all for attending.
Yep. Take care.
Yeah.